Although we often refer to ASAP as a ray tracing program, ASAP can be used to trace light from either coherent or incoherent systems. Let's take a look at propagating a coherent wavefront through ASAP. In this particular file, what we're going to look at is what happens as light propagates through an Amici prism. We've defined the Amici prism itself with bare surfaces, so we're going to see some Fresnel effects. And to tell ASAP we're going to do coherent analysis, we simply have to add a few more commands to the ASAP script file. In this particular case, just telling ASAP to do a coherent analysis. But in this case, we're also going to define an input linear polarization. So what we're going to do is see what happens to the coherent wavefront and the polarization state as we propagate the light through the system. And let's just take a look at the results. In this particular case, we're actually going to propagate the wavefront in steps. First, we're going to propagate the wavefront simply through the prism and take a look at the polarization state. Then we're going to propagate the rays the rest of the way through the system and take a look at the image results. So again, initially we'll just propagate through the prism and take a look at the polarization state after the light is propagated out of the prism. And we can see that our input linear polarization state is now elliptical. Then we'll trace the wavefront the rest of the way through the focusing element to the image location, and we can do any other type of analysis at that location, coherent analysis, and in particular now we're looking at the coherent polarized point spread function, and we can see the effects of the aberrations in the lens as well as the shape of the coherent wavefront.